So up to the fifth chapter, whatever we learn, right? So uh, how many types of currents are there, right? How many types of current? So up to fifth chapter, we only talked about the currents where the voltage was constant, right? Or the current was constant. So let's say we have time, right? And then we have this voltage. So this voltage was constant, right? So this was called or let me also write it as current. So current was not fluctuating. It was constant over a period of time, right? So this was called the direct current or DC. So this is a direct current. Okay. And what is the supply of direct current? So the cell or battery gives the direct current, right? Where your current is not fluctuating. But let's say you have some current which are fluctuating over time. So okay, so you have one moment. Give me one moment. Okay, so yeah, sorry about that. So now we, in some cases, it may happen that you have time and you have some current. So this would be fluctuating, right? So it may happen that current is fluctuating. So it is increasing and then decreasing and then increasing again. So these type of current are called alternating current, right? And where do you get these kind of currents? So you get these kind of current from AC generators or dynamo or generators. Okay, is this part clear to you, Aisha? Yeah. So in most of your mobile devices, what is the current that they prefer? Yeah. So the supply is, let's say, in your household, right? In your household, you get an AC current or AC voltage, but your devices uses the DC current. So that is why you have some transformer which transform these AC current to DC current. We'll talk about that later. But yeah, so did you understand this part, DC and AC current? Yeah, so please note it down and then we'll talk about the AC generator. Yeah, whenever you need me to scroll down the screen, you please tell. Done. So please note down. Yes, noted, Aisha. You are right. Okay, noted. Okay. So now let's talk about how do we get this AC generator. So in the previous chapter, electromagnetic induction, we understood that we can get an EMF generated or we can get an induced current when we change the flux around the coil, right? So using that principle, Nikola Tesla, right? So Nikola Tesla came up or invented the AC generator. Okay. So you can see that. So you can see that in your household, in your so many things. So electricity, actually, Nikola Tesla came up with the electricity, right? So nowadays we have these electricity supply. So Nikola Tesla gave us the electricity. And using what? Using electromagnetic induction, right? So that is a very powerful theory. Electromagnetic induction is a very powerful theory. So you can generate so many megawatts of energy, right, or power from this idea of electromagnetic induction. So can you give me some examples where you see that these AC generators are there? Can you do you have some idea? Okay, so first let us talk about this AC generator, and then we'll see what are the uh, how many types of AC generator are there. So what is a AC generator? So it is a device. Oh, now Mariam is joining. So it is a device which converts mechanical mechanical energy to electrical energy, right? So this is a AC generator. You have a coil, you mechanically rotate that coil, you change the flux, and then you can generate the electrical energy. So what does the AC generator do? It converts the mechanical energy, right, to the electrical energy. And what is the principle of AC generator? Good evening, Mariam. Assalamu alaikum. You got late. You got late. So we just discussed that what is the direct current. So up to fifth chapter, whatever we were learning through the cell, right? So we understood that cell EMF. So that was the example of direct current. And what is a direct current? So in direct current, the current remains same over the time. So it doesn't fluctuate, right? And similarly, you have this alternating current. So in the case of alternating current, the current changes over time. So that is why you get a fluctuating current, right? And from where you get this alternating current? You get from AC dynamo or generators. So now we are talking about this AC generator. So Nikola Tesla invented this AC generator, and it has a very big commercial use as well as the home appliances, but it has a very big commercial use, right? So your trains, your power plants, your nuclear reactors, all those things uses this idea of AC generator, right? So you have hydropower plants and you have coal, right? And then you have nuclear reactors. So all those things uses the idea of this AC generator, uses the idea of this Nikola Tesla that he came up with, right? Okay, so yeah, what is the principle of AC generator? So it is based on the electromagnetic induction given by Faraday's law by changing the flux through an area and subsequently generating an EMF. Okay, so EMF. This is the principle of the AC generator, right? Now, what is the construction of an AC generator? Right, so you have some magnets, right? So how how do you how, draw? Let's say I take I take that I wanted to draw a beautiful drawing, but it is not working. So, what is the construction of an AC generator? So you have two permanent magnets, right? And this is north and this is south. So magnetic fields line are going from north to south, right, guys? So this is the magnetic field line, and then you have a coil, right? So then you have a coil which is placed in this magnetic field, right? So and and then you have these okay, so and then these so these are carbon brushes and EMF is generated here. So these are carbon brushes. And then you have these circular thing which are slip rings, right? So these are connecting these circuits, okay? And this coil is called an armature or amateur or what was it called? So this is a coil, right? Armature, okay? And it has an axis, perpendicular axis, right? So this is axis. Okay. So this is the basic construction of a AC generator. So what do you do is that you have, let me show you. Okay, so what do you have? So let me bring this. Okay. So this is a coil, right? This is a coil, and let's assume that in these two sides you have some magnetic field. So magnetic field are going in this direction, right? And you have this area. So if this is in this way, so what is the angle between the area and the magnetic field? If I have placed the coil like this, so what is the angle between area vector and the area vector and the magnetic field? Yes, guys, Mariam and Aisha. I have placed like this. So this is my surface. This is my surface, right? This is my surface. So what is the angle between area vector and magnetic field? What is that, guys? Yes, uh, 90. Your voice is breaking. Can you write it in the chat box? 90, okay. So now tell me if this is the area, then the area vector is normal to this one, right? Area vector is normal to this one. So area vector is this, magnetic field is this. What is the angle between area vector and magnetic field? Yes. Now what is the area, Mariam?
Zero.
Zero. Right. So it is zero, guys. So and what you do is that, so what you do is that then you rotate this one, right? So you rotate it by 90 degrees. So now where is the area? Where is your area? Perpendicular, right? Normal to this. Magnetic field is this. So this is your uh, area vector, and this is your right. So this is your area vector. This is your magnetic field, right? So the angle between the area vector and the magnetic field has changed, right? Okay, one moment, guys. Okay, so sorry about that, guys. Where was I? Yeah. So, firstly, the angle was this 0 degree, right? Now the angle changed to this. And then if I rotate, so this is my coil, and then I rotate it again. So now what is the angle between the surface and the magnetic field? What is the angle? Yes. What is the angle between the surface and the magnetic field? Yes, Aisha and Mariam, guys, what is the angle? Normal to, yeah. So your, this is your coil. So area is in this direction. Area is in this direction, right? And magnetic field is how it is 90. It is 180. 180, right? So first is it was this, then it goes here, and then it goes here. So 180, right? And then again this goes here. So I this was my coil. I rotated it like this, then I rotated it like this, and then I rotated it like this, right? So then my angle is this. So how much is this total angle? How much is this total angle? Yes. How much is this total angle? This was 180. Then what is this angle? Oh, I have an answer. Yeah, 3 pi by 2. 270. Yes, absolutely right. So 270. And then I rotate it again. So you guys can see that how am I changing the flux? How am I changing the flux? I have this flux which is VA cos theta, right? Am I correct, guys? Correct. So what is that? So I have to change this flux, right? And from the example or from the demonstration, you guys saw that what is that I am changing? Yes. Am I changing the magnetic field? Am I changing the area? So I am changing this angle, right? This was 0, then 90, then 180, then again 270, and then. So I am changing the area. Understood, everyone? Yeah. So your from Faraday's law, right? So from Faraday's law, what is happening? This is EMF generated is minus of d phi by dt, right? And let's say that I have, let's write. So what is that I have? So I have the number of turns of coil. So this is number of turns of coil, right? And I have the magnetic field, and then what do I have? I have this area, right? Area of the coil, and then I have this theta, right? So I have this axis, right? And I am changing this theta, right? So this theta is changing with omega t, where omega is my angular velocity, right? So you guys know that omega is this angular distance divided by time, right? So this theta would be omega t. Understood? Understood, everyone? So this would be, this EMF generated would be how much? This would be minus n d and then VA cos of omega t divided by dt, right? Your B is constant, A is constant, so it is taken outside. So this is minus n VA and then d by dt of cos omega t, right? So EMF generated would be how much? This is minus NVA. And what is the differentiation of cos omega t? Yeah, so that would be minus sine omega t. But I have to apply the chain rule. So if I take the differentiation of cos omega t, right? So this would be minus of sine omega t. And inside I have another function, that is omega t, right? So this would be d by dt of omega t. So then this omega would be outside, so this would be minus omega sine omega t. Is this clear?
Yes.
Okay, so then this would be omega. So if I write this properly, so this would be nba omega and sine omega t, right? So this is a fixed value, and let me write it as E naught. So E naught sine omega t. Okay. And I will talk about this one in a moment. So as you guys saw that when my theta was zero, my flux was zero. So I got this was zero, right? And when my theta became 90, right? So I had the maximum value. And then when my theta became when my theta became 180, so again this was zero, right? And then when my theta became 270, so this was in the minus, right? And then I got the full rotation. So this theta is 360. Then again I got the zero, right? So this is how my voltage EMF is changing. Understood, everyone? So in this axis, I have, let's say, omega t, and in this axis, I have, let's say, this is E, right? Or let me write it as. So you guys can see that this is what point? This is what point? Yeah. So this is the maximum value, right?
Yes.
So at this point, my EMF is maximum, right? So this is E naught. Okay. And that is what I call this E naught here. So this is my maximum EMF generated, right? Maximum EMF. Okay. And you guys can see that this EMF is a varying one. So this is a varying EMF, right? I don't have a voltage which is constant over time. I have an EMF which is fluctuating. Okay. So then this will create a current which would be fluctuating, right? So in the previous example, We were writing the cell as this, right? So this was representing a fixed EMF, right? But now in this chapter, we will represent the EMF like this, right? So this will represent the fluctuating, this is V, which is V naught sine omega t, or E, which is E naught sine omega t, right? So this is a fluctuating voltage. Is this part clear?
Yes, sir.
So you saw that by changing the angle, we can generate the EMF using the electromagnetic induction. So you guys note up to this point, and then I'll talk about some other things. So I will give a question and then, yeah, so you guys note down from here. So any confusion in AC generator?
Yes.
Please note it down. And whenever you guys want me to scroll down the screen, guys, please tell. Okay. So Yeah, whenever you guys want me to scroll down, you guys please tell. Yes, guys, noted.
Thank
Is this is theta. So where E naught is, this is maximum EMF, and this is NBA omega. Done. Okay, so note down this part. Noted, Mariam and Aisha. This, yeah, so this is how we represent varying. Okay, so now, oh, 1 minute. Oh, sorry, sorry. So Done, Maya. Okay, so now let us do an NCRT problem and then we'll talk about the other things. Yes, so now what do we have? We have this question, right? So we have this question. So Kamala, right, pedals a stationary bicycle. The pedals of bicycle are attached to a 100-turn coil of area. So what are the things which are given, right? So we are given that. So we are given that. Okay, 100 tons. So N is given, right? And area is also given. So this is 0.1, 0, which is 1 meter square. And then the coil rotates at half a revolution per second, right? So full revolution is how much? Full revolution is 2 pi, but half revolution, right? So this is the omega. So omega is pi. Okay. So half revolution, right? One revolution is 2 pi distance, angular distance. Half revolution is pi distance, right? And per second, so time. And then magnetic field is, so omega is pi and magnetic field is 0.01 Tesla, right? So what is the maximum voltage generated to the coil? So we have to calculate what is E naught. So you guys have already seen that what is the E naught? Yeah, what was the E naught? What was the maximum voltage generated? Check your notebooks, guys, and tell me.
Unit.
Yeah, NAV omega, right? So you guys please calculate and tell me what is the value that you guys are getting. Yes, tell me, guys, what is the value that you guys are getting? Aisha, and what is the value that you guys are have I right? 31 point. So Mariam got 31.4. Aisha, what are you getting? 0.0314. Right. So Mariam and Aisha, you guys are in disagreement. So this is number of turns are 100. A is zero point 0.1, right? Then this is 0.01 and then this is 5. So 100 and 0.01. So this cancels, right? Then zero point 0.1 into 3.14. So this would be 0. How many? So this would be 314, but 0. So this is 10 and this is 100. So 314, 314 divided by 1000. So 0.31. Right. So what is the answer, guys? 0.31. Understood? Understood, everyone?
Yes.
Okay. So, yeah, this you already have calculated, right? So this you don't need to note it down because, yeah, you please correct your calculation and then we'll do the other topics. Please, whenever you have corrected your mistakes, please tell me, then we'll what? Corrected, guys?
Yes.
Okay, good. So now let us understand about the other things. But before I do that, right? So we generated this EMF. We generated this EMF by rotating this coil, right, everyone? Yes. So there are number of ways in which we can rotate this coil. So first one is the hydro power plants, right? So from where you are getting so you have a fast flow of water currents, and in that water currents, this coil is placed. So then this coil will rotate, and then you will get the AC generator. So then you will get the EMF. So that kind of AC generator are called hydro plants, right? So I'm just naming a few AC generators, right? So first one is this hydro power plants, right? Okay, and then in trains, right? Or in the whatever you have these coal industries, right? So you have these powerhouses. So in that, what do they generally use? So those are actually the coal plants, right? So in the coal plants, what you do is that you burn the coals and then some water vapors are generated, and those vapors are very high pressure water vapors, and then they move the coils. So from that you get this AC generator. And then you have this third one, which is the nuclear reactors. So through nuclear reactions, you move those coils, right? So these are some example of AC generators, and in modern day generators. So in modern day generators, you can create 500 million watt or megawatt supply, right? So this is megawatt supply of voltage, right? So how much is this? So you have 100 watt bulb, right? So you have 100 watt bulb. Nowadays, the power of the bulb is how much? Do you guys remember? So you guys have bought the bulbs, right? LED bulbs. So what is the power of those bulbs? Yeah, you guys have those LED bulbs. So have you guys seen the power of those bulbs? Don't remember. So the power of these LED bulbs are 7 watt, 5 watt, or 9 watts, right? These are the LED bulbs nowadays that you have. But we have this 100 watt bulbs also, right? So you can see that this is 500 and then this is 10 to the power 6. So 500 and then 10 to the power 6. 10 to the power 6 is million. So 500 million 100 watt bulbs you can, not 500, but 5 million, right? So 5 million 100 watt bulbs you can grow, right? Using the modern day power supply. So this much power is generated through the modern day generators, right? 5 million bulbs. Can you imagine? 5 million bulbs. And that is of 100 watt, not this 7 watt, 5 watt. So 5 watt, you can assume that how many 5 watt bulbs. So in our houses, generally, how many bulbs do we have? Let's say 10 or 20. So you can glow so many households, right? Using this 500 megawatt supply of voltage. Okay. And generally in India, the frequency of rotation. So you are rotating those coils, right? So in generally in India, right? In India, the frequency of rotation of the coil, frequency of the rotation of the coil is how much? You guys have known this. So this is 50 hertz, right? So in India, you generally get 50 hertz and 220-volt supply, right? In your household. This is what you get. So this 50 hertz mean that this is the frequency of those coils that they are using in the powerhouses. And in America, the frequency is 60 hertz. Okay. So these are some general information that you guys should remember. These are not from the examination point of view, but These are important. Do you guys want to note down these things? What happened? Yeah, do you guys want to note down these things?
No.
If it is not needed, then let's move on to the next thing. So what do we have? We have an AC supply, right? An AC supply, and which is what? So this is how we represent. This is E naught sine omega t, right? So this is the instantaneous EMF, generated. This is the maximum EMF generated, and then this omega is the angular velocity. So these are the important things of a AC supply, right? Now we will calculate some important things. So first one is this average instantaneous EMF. So average EMF. So first thing is average EMF over a full cycle, right? So over a full cycle means that the EMF was generated, and so this is from here to here. This is one cycle, right? So this is called the one full cycle. So from here to here, the time is t, right? And this is t by 4. This is t by 2. This is 3t by 4. And then this is 4t by 4, which is t, right? So this is the full cycle. So in full cycle, what will be the average? Okay. So before we do the average, this is important to note that average of a function, right? So this would be, let's say this is ft. So this would be integration of ft dt from 0 to t divided by 1 by t. So this is the average of a function. Clear, everyone? Is this clear, guys?
Very explainable.
Okay, so you want to note it. I will give you the time to note it. Okay, so then please note it down. Yeah, you guys note it down, and then we'll calculate the average. So whenever you guys have noted, please say. This is yes, right, and then this is, and this is the time. So whenever you have completed noting it down, please tell me, guys. Whenever you guys have completed noting it down, please tell. Noted, Mariam. Yes, I shared Mariam. Did you guys note it down?
Yes.
Okay. So now let us calculate average EM. So how do we represent that? This is E, right? This is how we represent the average. So you guys tell me that what would be this average EMF? Through this definition of average, this would be 1 by T, right? Integration of 0 to T and E dt. Am I correct, everyone? Correct? So this would be, and now we can put the value of, so we can put the value of E, so this would be 0 to T and then E naught sine omega T dt, right? Okay, so this would be E naught is constant, so we can take it outside. And then this is E naught by T and integration of sine omega T dt. And then this is from 0 to T, right? So what we do is that we have this E naught, right? And integration of sine theta is how much? So integration of sine theta is minus of cos theta. Okay, everyone. Understood? Yes, guys, understood?
Yes.
And so in here we have this omega t dt, right? We have this multiplication. So we have to put, let's say, put omega t equal to theta, right? So if I calculate dt by d theta, right? So this t is a variable, this is theta, right? So if I calculate that, then omega would be outside. This is dt by d theta and then d theta by d theta. Is this part clear? I am taking the differentiation with respect to theta. Understood? Clear, everyone?
Yes.
So this is w and then d theta dt by d theta and then 1. So I take this d theta in this side. So this is omega dt equal to d theta. Okay. Any doubt up to this point? Yes. Do you guys have any doubt? So what I did, I put omega t equal to theta. Omega t equal to theta. So and then I took the differentiation in both the sides. So this is constant. Omega is constant, so dt by d theta and d theta by d theta. This is 1. And then this is d theta by dt by d theta. So I take d theta in this side. So omega dt is d theta. So what is the value of dt? Dt is d theta by omega. So you guys are saying that what is the use of this? So now what I did was that I have changed this integral. So I have put omega t equal to theta. So this is sine theta, right? And dt is how much? This is d theta by d omega. Okay. The limits would be changed, but I will put back these values. So this is E naught by T, and then what do you have? You have omega is taken outside, and then 0 to T sine theta d theta. Okay, so this is E naught and T omega, and this is minus of cos theta, right? And this is from T to 0. So I can put back theta value. So this is minus of E naught by omega t, and this cos theta is cos omega t. So if you guys have any doubts, so you can stop me in the middle and ask any questions, right? Understood? Yeah. So if you guys have any questions, you can ask, right? So then I can put back. So my function is cos omega t. And in place of t, I have to put t and I have to put 0. So this is omega t and then cos omega t minus of cos omega into 0. So this would be minus e naught omega t and cos omega t minus of cos 0. So we have to find out what is this value, right? So who got disconnected? Oh, Mariam got disconnected. So can you, Aisha, can you tell me what is the relation between omega and time period? What is the relation? This is, remember, this is angular velocity, right? And this is full cycle time period. So do you remember in full cycle how much distance is covered? Angular distance? In full cycle, how much? So this omega is distance, right? So this omega is angular distance by time, right? So this omega and in full cycle, how much angular distance you cover in full cycle? In full cycle, how much distance you cover?
Yes.
360, which is 2 pi, right? So, so this would be 2 pi and the time that you have taken is t. Understood?
Yes.
So this t would be 2 pi by omega. So now you place this value in here, so you will get E naught omega t, and this is cos 2 pi by omega is 2 pi by t, right? Or you can change t or you can change omega. So let's say you change omega, so this is 2 pi by t into t. This cancels and this is cos 0. So what is cos 2 pi? Aisha, what is cos 2 pi? What is cos 2 pi? What is cos 0?
Cos 2 pi over 1.
1. Absolutely right. So cos 2 pi would be 1. Absolutely right. So this is 1 and then this is 1. So 1 minus 1 is 0. So you'll get 0. So average of E would be 0. I could have written this value directly, right? I could have just written that integration of sine omega t dt from 0 to t would be 0. But how this comes, that would be the question. So this is how your sine omega t dt is given, right? What you do in this integration, so this is you have to be careful. So what you do is that first you put omega t equal to theta, right? And then you differentiate and then you put the value of omega t in here. So this will be changed. And then this would be sine theta d theta. And you know the integral. So after that you integrate and then you'll get this value. Okay. Any doubt in this, Aisha?
No, sir.
Okay, so this much you have calculated. So please note down from here. Okay, so please note down from here. So you see that average EMF would be 0, right?
Yes.
Whenever you want me to scroll down the screen, please tell.
Comes
Then please note down this part. Yes, Mariam, you got disconnected. So yeah, so okay. So what I will do is that I will put the screen and you, Mariam, you please note it down. So, but Aisha, did you note it down?
Yes, sir. Done.
Done. Okay, so Mariam, what we did was that we were calculating this average EMF, right? Okay.
Yes, sir.
So what we did was that we put the value of E, which is E naught sine omega t, and then we had this integral of sine omega t dt. But we know sine theta d theta. We don't know what is a function of sine theta d theta. So we changed this integral by putting omega t equal to theta, right? So when we put omega t equal to theta, then we have to find out what is this dt. So to find that, we differentiated both the terms. And then we got dt by d theta. So we got dt equal to d theta by omega. And this omega is constant. So we replaced dt, we replaced sine omega t. So sine omega t becomes sine theta, dt becomes d theta by omega. And this is constant, so it goes outside. And now we have to take the integral of sine theta d theta. So that we already know that is minus of cos theta. And then we put the limits. So the function was, and then finally we actually put the function which was the original function. So in place of theta, we again put back omega t. And then we solve this, and then we got 0. So you please take the screenshot. Okay, where should I put the screen? Yes, Maria, is this okay to put the screen in here? You please take the screenshot, and I will explain it again in the next class. Yes, Maria, did you take the screenshot?
Yes, sir.
Okay, so please take the screenshot of this part as well. And finally, what did we get? So after doing this much of calculation, we got average EMF uh, by the generator is 0. Okay, so remember this was in the full cycle, right? And in the next class, yeah. So Mariam, did you take the screenshot?
Yes, sir.
Yeah. So in the next class, we will learn about the half cycle. So half cycle is this one, right? So time would be t by 2. So in the next class, we will learn that what is the integral from 0 to t by 2, right? So yeah, I'll stop it here, and in the next class, I will start from the average EMF in the half cycle, right? So in your school, what is the chapter that they are currently doing? Yes, Aisha and Mariam. In your school, what is the chapter that they are currently?
So the same when we're doing here.
Yeah. What they are doing?
Alternating current.
Alternating current. Oh, good, good. So okay. So did they complete this average EMF?
Yes.
Good. And Mariam, what about you? What they are currently doing in your school? Yes, same. Maybe you're talking, but I'm not able to. Okay, so we'll stop it here, and yeah, see you guys in the next class, right?
Thank you,
So
sir.
yeah, Allah Hafiz, guys. Bye, bye.
Thank you, sir.
Yes, bye, bye.